Welcome to our channel. This is part 2 of our last video, the periodic classification of elements, where we talked about the periodic classification of elements and many more. So if you haven't watched it yet, go watch it right now. In this video, we are going to talk about the periodicity of elements in the periodic table. For periods 2 and 3, ongoing from left to right, the atomic number and electronic configuration keep increasing, and the valency increases from 1 to 4, then starts decreasing up to 0. Take a moment to analyze this picture carefully. In general, the number of valence electrons of a presentative element is equal to the group number. Lithium has 1 valence electron. Beryllium has 2 valence electron. Boron has 3 valence electron. Carbon has 4 valence electron. Nitrogen has 5 valence electron. Oxygen has 6 valence electron. Fluorine has 7 valence electron. Neon has 8 valence electron. Based on the filling of electrons in the valence orbitals, the elements can be classified as S-block elements, P-block elements, D-block elements, and F-block elements. In the atoms of elements of group 1A, only the outermost shell is incomplete with 1 electron. The elements of group 1A have 1 electron in the valence shell. They are monovalent. Group 1A elements are known as alkali metals. They are called alkali metals because their oxides are water-soluble and they form strong bases when dissolved in water. Group 2A consists of alkaline earth metals. They are as follows with their atomic numbers and their electronic configuration. In the atoms of elements of group 2A, only the outermost shell is incomplete with 2 electrons. The elements of group 2A have 2 electrons in their valence shell. Hence they are divalent. For example, magnesium hydride and calcium hydride. The atomic radius of atoms generally decreases from left to right across a period. Within a period, protons are added to the nucleus as electrons are being added to the same principal energy level. These electrons are gradually pulled closer to the nucleus because of its increased positive charge. Since the force of attraction between the nucleus and electrons increases, the size of the atoms decreases. The effect lessens as one moves further to the right in a period because of electron-electron repulsion that would otherwise cause the atom size to increase. There are some small exceptions, such as the oxygen radius being slightly greater than the nitrogen radius, which is due to electron-electron repulsion. The atomic radius of atoms generally increases from top to bottom within a group. As the atomic number increases down a group, there is again an increase in the positive nuclear charge. However, there is also an increase in the number of occupied principal energy levels. Higher principal energy levels consist of orbitals which are larger in size than the orbital from lower energy levels. The effect of the greater number of principal energy levels outweighs the increase in nuclear charge, and so the atomic radius increases down a group. Atomic radius in a period it decreases while in a group it increases. Atom sizes are relative to the largest element. Cesium dimmed elements have no data. Elements 87, 88 and 104 to 18 have no data and were omitted. The elements can be classified as metals, nonmetals, or metalloids, as shown in the figure. On many periodic tables, a jagged black line along the right side of the table separates the metals from the nonmetals. The metals are to the left of the line, except for hydrogen, which is a nonmetal. The nonmetals are to the right of the line, and the elements immediately adjacent to the line are the metalloids. Metallic character decreases as you move across a period in the periodic table from left to right. This occurs as atoms more readily accept electrons to fill a valence shell than lose them to remove the unfilled shell, and metallic character increases as you move down an element group in the periodic table. This is because electrons become easier to lose as the atomic radius increases. Where there is less attraction between the nucleus and the valence electrons because of the increased distance between them, electron affinity reflects the ability of an atom to accept an electron. It is the energy change that occurs when an electron is added to a gaseous atom. Atoms with strong effective nuclear charge have greater electron affinity. Electron affinity is the amount of energy required to detach one electron from a negatively charged ion of an atom or molecule. Electron affinity follows a trend on the periodic table. It increases moving down a column or group and also increases moving from left to right across a row or period, except for the noble gases. Electron affinity is the energy change accompanying the addition of an electron to a gaseous atmosphere. As you move down a group, electron affinity decreases. As you move across a period, electron affinity increases. Period trend. Electron affinity increases as you move across a period because atoms become smaller and the nuclear charge increases. This means there is a greater pull from the nucleus. Group trend. Electron affinity increases as you move up a group, or decreases as you move down a group, because of the size of the atom increases. Example: which element has a greater electron affinity, Pb or Sn? Take a moment to study this figure. Energy change that occurs when an atom accepts an electron. Halogens have the highest electron affinities. Metals have low electron affinities. Affinity tends to increase across a period and decrease down a group. What is ionization energy? Ionization energy is a measure of the amount of energy needed to remove electrons from atoms. As electrons are negatively charged and protons in the nucleus are positively charged, there will be an attraction between them. The greater the pull of the nucleus, the harder it will be to pull an electron away from an atmosphere. First, ionization energy. Definition: the energy required to remove 1 mole of electrons from each atom in 1 mole of gaseous atoms to form 1 mole of gaseous positive ions. What is ionization energy? It is a certain amount of energy that is necessary to knock off electrons from an atom to form a positive ion. The value of the first ionization energy depends on the electronic structure. The value for helium is higher than that for hydrogen because there are now 2 protons in the nucleus. The nuclear charge is greater, so the pull on the outer electrons is larger. More energy will be needed to pull an electron out of the atmosphere. Let's know more about ionization energy. Amount of energy required to remove the highest energy electron from an atmosphere, or steal 1 electron. What happens down a group? Decreases. Since the size of the atom is increasing, the attraction is weak between the outer shell electrons and the nucleus. Therefore, electrons are easier to remove. What happens across a period? Increases. Since there is an increase in core charge, the attraction is greater between the outer shell electrons and the nucleus. Therefore, electrons are harder to remove. Atoms on the left of the periodic table give up electrons easily to achieve a more stable electron configuration. The valence electrons in atoms lower in the group experience less pull from the plus protons in the nucleus and are easier to remove. The noble gases have the highest IE of all because they are in the most stable configuration. Ionization increases in from left to right in a period, and decreases going down in a group. Recap: atomic radius decreases from left to right across a period of elements, and increases going down a group. Metallic tendency increases going down a group. Non-metallic tendency increases going from left to right across the periodic table. Electron affinity increases across a period in the periodic table and decreases down a group. Ionization energy increases from left to right across the periodic table, and decreases going down a group. Thank you for watching this video. Please give this video a thumbs up and also subscribe to our YouTube channel. And also let us know in the comments section below what more videos you would like to watch next.